Well, this is John Black, Super Chemist, Polarizer's Fundamentals, and the 3 polarizer paradox.
But even at 1 degree, right? There's a spot over here that's the very end over here. Not the rest of this gets in, but if it's the B field is way down here, you don't get in. That's why you have a chance to get in at 89 degrees, and you have a chance not to get in at 1 degree. And why everything oscillates? Because it oscillates towards this. This would be the same as the B field. Look. He has 180 data points, meaning he could have went from 180 degrees down to 179, all the way down to 0 degrees and showed all of the percentages. So he has 180 data points. He uses 3. Is that what physicists do, or is that what lying pieces of human garbage do?
What's strange about that last number is that you might expect it to be more like halfway between 50% and 100%, since 22.5 degrees is halfway between 0 and 45, but 85% is significantly higher. To see concretely how strange this is...
It's just so strange. He can't understand this. He's dumbfounded. He doesn't understand why when you have an object that oscillates its position, the probabilities would oscillate, because that makes no sense to him. This grown man knows that the photon has 2 oscillating fields, E field, B field, and he induces, jiggling, the E field and the B field, and the polarizer goes off too. That's 4 oscillating fields. Everyone involved has 2 oscillating fields, and yet he still thinks that the probabilities, percentages, should be uniform, like 100%, 75%, 50% instead of this. Instead of oscillating exactly like all the fields are doing. He thinks that the probabilities, right, should be uniform, and he does not think that it should be oscillating, the probability percentages, even though everything involved has 2 oscillating fields. Really. And he thinks that he's not an idiot?
Of our 3 filters, A oriented vertically, B oriented 22.5 degrees from vertical, and C oriented 45 degrees from vertical. We're going to compare just how many photons get blocked when B isn't there with how many get blocked when B is there. When B is not there, half of those passing through A get blocked at C.
Yeah, because you turn your difference of 45 degrees, so you get half.
That is, filter C makes the lamp look half as bright as it would with just filter A.
And then what does it do, though? It rotates it to this. It doesn't just go through this filter. He knows it, because he says when it comes out, it's all in this order right here. He knows he rotated it. Of course, it's leprechauns.
Half as bright as it would with just filter A. But once you insert B, 85% of those passing through A pass through B, which means 15% are blocked at B. And 15% of those that pass through B are blocked at C. But how on earth does blocking 15% twice add up to the 50% blocked if B isn't there?
All these filters do is remove light.
Notice he doesn't bring up that he's rotating it. Obviously that makes a difference. If you rotate it, you moron, freaking moron. That's what it's not that he doesn't understand it. It's that he tells you to your face and my face, hey, I know that it comes out rotated, but I'm going to never bring that up when I bring up the magic. Okay, I'm never going to bring it up. I'm going to say that when I put this middle filter in, nothing is changed about the light, so I don't understand what's happening. All I did was rotate it, but by rotating it, that doesn't do anything. Obviously, I didn't do anything to the light. What? It must be leprechauns.
All these filters do is remove light. All these filters do is remove light.
Well, it doesn't, which is why the lamp looks a lot brighter when you insert filter B. But it really makes you wonder how the universe is deciding which photons to let through and which ones to block.
Well, they're oscillating their B field back and forth, right? I guess, that energy goes here to here to here, right? Here to here to here, right? So the B field's position oscillates back and forth. What do you expect? The B field is given, when you're diagonal, you get that torque. When you're vertical or horizontal, you get 0 torque, right? Because even if you induce a current, it's the same. It produces the same E field and B field. They're parallel. There's no torque involved. If the B field oscillates back and forth, obviously it's you know, it's going to be on the ends a lot longer than in the middle. It's moving faster in the middle, right? So so your probabilities, whether you know your torque, you get more torque while it's over here. Over here, you get zero torque. You know what I mean? Yeah, and that's oscillates. So the probability would oscillate. This is ridiculous.
In fact, these numbers suggest that it's impossible for there to be some hidden variable determining each photon's state.
What's funny is you might as well just draw the B field, right? B field. I'm an idiot. B field. It can't. And then while he tells us it can't be. There's no. And we can't figure this out. While he draws a picture of basically the B field. He never brings up the B field. You know. Does he know there's a B field? Do these people know there's a B field?
With respect to each filter. In other words, it suggests that it's not even possible for these photons to have some definite answer to the three questions: would it pass through A, would it pass through B, and would it pass through C, before those measurements are actually made. What we'll do here is a proof by contradiction. Imagine 100 photons who do have some hidden variable, which through whatever crazy underlying mechanism you might imagine...
Yeah, B field oscillating back and forth. That's crazy. That never happens. There's no such thing as a B field. An oscillation? No, B field doesn't oscillate the B field. No. and he never... Notice how he never, ever, when he's talking about the magic, right, never brings up the fact that when he goes through this middle filter, you're rotating the photons. You're changing them so that they're close to this 90 degrees, or more close rather, you know, or more. Like, what? Are you insane?
Determines their answer to these questions. And let's say that all of these definitely pass through A, which I'll show by putting all 100 inside this circle, representing photons that pass through A. Now, if you want to produce the results that you see in experiments, about 85 of these photons would have a hidden variable determining that they pass through B. So let's put
It's not a hidden variable, you moron! It's actually worldwide known that the B field oscillates. And if you have an E field oscillating, then you got the B field oscillating, okay? Which means you're going to induce jiggling in the polarizer with its E field. And that jiggling of the E field in the polarizer will make a B field in the polarizer. Now you have two B fields, one in the polarizer, one in the photon. And if the photon's going back and forth, then B field and the polarizer is going back and forth. They're oscillating. They're going to do torque with that. That's going to be torque. And you know, it depends on your angle of if you're going to get a lot of torque or a little torque. Like, this isn't like some calculus big whatever, you know, it's hard. Oh, it's so hard to... No, this is little 3-year-old stuff, you moron.
85 of these guys inside the intersection of circles A and B, leaving 15 in this crescent moon section representing photons that pass through A but get blocked at B. Similarly, among those 85 that would pass through B, about 15% of them should get blocked at C, which is represented in this little section here, that's inside circle A and B, but outside circle C. So the actual number whose hidden variable has them passing through both A and B, but not C, is certainly no more than 15. But now, think of what Henry was just saying. What was weird was that when you remove filter B, never asking those photons what they think about 22.5 degree angles, the number that get blocked at C seems too high.
You know, this would be like, there's a square hole in the ground, okay, and you have square blocks, and you're throwing the square blocks through the square hole. Some of them make it, some of them don't. But they're both square, so that it's possible. And then I come in, okay, right? And you're getting 50% of the stuff there, right? You know, and I come in, right? And I switch your blocks into spheres that are bigger than the square hole. So it's impossible to get it in. You know what I mean? And then you're like, I don't understand. I've been getting 50%. And then all of a sudden, no one changed anything, you know, even though I came in and changed the square balls into, you know, spheres that are too big, you know, to fit in the hole. Even though I did that, the person says, nobody did nothing to them, but all of a sudden, my probabilities went down to 0%. I don't get it. No one touched my balls, nothing. It's like, no, someone came in, switched your cubes into spheres. They were too big to go into the square hole, you idiot. Okay, this guy came in, he put a filter in that rotated all the light so that it's more close to this 45 degrees. So obviously, you're going to have more coming in up here than you do down here. There's a 45 degree difference when it goes through this filter. Up here, even though it's 45 degrees and this is 45, the light coming in is only 22.5 degrees off. Here, it's 45 degrees off coming in. So, what? And you're confused? You're confused why, when light comes into this 45 degree angle filter, light that's only 25%, 22.5% difference, differential, has light coming through more than this one that has a differential of 45 degrees from the light coming in. And you're confused why. Really? And keep in mind, this is exactly how antennas work, with the percentages and the ratios and etc. Nobody bats an eye.
So let's take a look back at our Venn diagram. What does it mean if one of these photons has some hidden variable determining that it should pass A but get blocked at C?
I don't know, every time he says, it's almost like he knows. I mean, I know he's just a stupid moron, but it's almost like he knows, and he's just like spitting in our face. Because every time he says some kind of hidden variable, it's not hidden, okay? It's worldwide known. The B field oscillates. If it oscillates, you're inducing into the filter. You're going to have two B fields, idiot. Like, come on, man. We just don't understand it. What could possibly be doing this? I mean, we got a B field, and then we have another B field in the polarizers. So we have two B fields. But they can't be reacting because no two B fields in the world has ever reacted. That makes no sense. Obviously, it's magic. Okay, that makes sense. It's up
Well, it means that it's somewhere in this crescent moon region, inside circle A and outside circle C. Now, experiments tell us that a full 50 of these 100 photons that pass through A should get blocked at C. But if we take into account how these photons would behave if B was there, that actually seems impossible. Either those photons would have passed through B, meaning they're somewhere in this region here that we talked about earlier of passing both A and B but getting blocked at C, and that includes fewer than 15 photons.
Notice how he still refuses. When he's talking about the light going through and he showed the whatever's and the light comes here to here to here, then all of a sudden he's like, yeah, we rotate it. But here, when he does this and he got all this math and this BS math, right, which is, yeah. Notice how he never brings up that he wrote the photons went through the second filter. He rotated it, so the plane that the E field oscillates in is rotated more closely to the third filter. So obviously more light can get through. Like, this is like insane.
Or they would have been blocked at B, which puts them in a subset of this other crescent moon region that represents those passing A and getting blocked at B. And that guy has 15 photons. So the number passing A and getting blocked at C should be strictly smaller than 15.
No, because you rotate. If you didn't rotate it, then yeah, then it would be a mystery, okay? But you literally put the middle filter in with the intention to rotate it, and then he'd tell it. That's what kills me, is then he tells us. They tell us to our face. I rotated the light when I put this middle filter in. And then they continue on. So since we didn't do anything to the light, you can see I didn't do anything. All I did was put this filter in that rotated it. So I didn't do anything to the light, and then everyone claps and says, you're right. Idiots.
Plus 15. But at the same time, it's supposed to be 50? I mean, how does that work? Remember, that number 50 is coming from the case where the photon was just never measured at B. And all we're doing here is asking, what would have happened if it was measured at B?
They're always with this measurement. No one gives it. They think that they're megalomaniacs. They think they're God. They think if they measure something that the universe gives a crap about them. Okay, the universe doesn't give a crap about you, your measurements, your perceptions. Okay, it's going to do what it does. Okay, you're an idiot.
Assuming that it has some kind of definite state even when we don't make that measurement. And this is what gives us a numerical contradiction. For comparison...
See, it's always got to be, like, if we don't measure it, yeah, if you don't measure it, then it ain't rotated. It's not that you measured it, it's that you rotated it, you idiot.